of this lesson is solving limits algebraically. And with algebraically, that means that we're not looking at a graph, but we're trying to use as many processes that we can think of in order to find the limit. So there's 4 different methods. There's really 5 different methods, but there's 4 methods that we want to talk about today. The first method is plug in. And let's say that you have the limit as x approaches -2 of x squared minus 4x plus 1. First of all, what you should do is you should always just try to plug in the thing that you're approaching. If you have a polynomial or a rational or something where the limit that you're approaching is just a number, then you can plug it in, and if you get an answer, then that's the limit. So when I plug in the -2, I would have -2 squared minus 4 times -2 plus 1. Work it out. So see, -2 squared is 4. -4 times -2 is 8. Plus 1 is 13. So 13 would be the limit. So then let's look at another example. The limit as x approaches -2 again, 2x minus 6 over x minus 2. Again, just always start by plugging it in, see if it works. Plug in a -2 for x on top. Plug in a -2 for x on the bottom and work it out. We have 2 times -2 is -4. -4 minus 6 is -10. -2 minus -2 is -4. You actually can leave it like that, but if you'd like to reduce it, you get 5/2. Alright, now plugging in doesn't always work. So let's look at this example. Alright, so if I plug in a -2, then I would have -2 squared minus 2 times -2 minus 8 over -2 squared minus 4. So on the bottom I get 0 because -2 squared is 4, 4 minus 4 is 0. And whatever the top is, it really doesn't matter. But because I have that 0 on the bottom, that means that plugging in is not working. Just because you have a 0 on the bottom doesn't mean that the answer is undefined. In fact, when we're doing these algebraically, most of the time there's an answer. So plugging in doesn't always work because you might end up with a 0 on the bottom or some other thing that doesn't work. So your second method is factor or simplify. If you have x squareds on top, you might want to combine them or something like that, or you can factor. I know that some of you don't remember factoring very well, but we're going to do that real quick. On the bottom, that is the difference of 2 squares. Difference of 2 squares is x minus 2, x plus 2. On the top, that's x squared minus 2x minus 8. I'm going to do this separately. If you can do this without doing a whole process, then that's great. I want to remind you of factor by grouping, just in case that you need to remember that. Let's say that there's a 1 in front here. Multiply, you get -8. You found the factors of -8 that add to give you -2. So that would be 6 doesn't multiply to give you 8. That would be a 2 and a 4. I need a -2 when I subtract, so that's going to have to be a -4. So you replace the -2x with 2 and -4. Now I'm doing the whole process. I know that some of you do not have to do this. If there's a number in front of x squared, it's a little bit harder, so I'm just going to show you the whole thing though. So with the x squared and the 2x, you can factor out a x, and you're left with x plus 2. With the -4x and the -8, you can factor out a -4. Change your sign when you divide out the -4. And then these two things have to be the same. That's one of your factors. And then whatever else you have left, that makes the other factor. So going back, this is x plus 2 and x minus 4. Now, after you factor it, get rid of things that you need to get rid of. So now, basically what we're saying is that we can find the limit as x approaches negative 2 of x minus 4 over x minus 2. So then we plug in the negative 2 and see if it works. Negative 2 minus 4 is negative 6. Negative 2 minus negative 2 is negative 4. You can leave it or reduce and you get 3/2. Okay, let's try another one. Alright, I want to remind you how to factor the difference of two cubes, or the sum of two cubes. First of all, you would try to make sure if you could plug in the 1 on top and bottom. Well, if I plug in a 1 on the bottom, I get 0 on the bottom. That's the reason I can't just plug it in, so I'm going to try to factor it. The top, I'm looking for things that multiply to give me 1, that add to give me negative 2. So that must be x minus 1, x minus 1. But the bottom is the difference of two cubes. So when you have cubes, I'll do it with x cubed minus y cubed, and then we'll go back. You take the cube root of each, which you get x minus y. Alright, you square the first one. You square the last one, that goes at the end. But then there's a middle term where you multiply that and change the sign. So you multiply whatever that is, and you change the sign. Last is always plus, because when you square either a positive or negative, you get a positive. The reason this term has to be there is because if you multiply all of this out, you have to cancel out every other term. And if you don't put that term in there, things don't cancel. So in this process, the cube root of x cubed minus 1 would be x minus 1. Alright, square the x, square the 1, multiply the middle, and change the sign. X times negative 1 is positive 1x, or positive x. Alright, things will cancel. If you're factoring correctly, usually things will cancel. So now I'm trying to find the limit of this. Plug in a 1. I do get a 0 on top, but when I plug in a 1 on bottom, I get 3. And since there's 0 on top, the answer is 0. It's okay for your answer to be 0. It's not okay for 0 to be on the bottom. Alright, one more factoring kind of problem. So x is approaching negative 3, and this is x plus 3 over 2x squared plus 5x minus 3. Alright, so I'm going to try to factor, and I'm going to do this factoring on the bottom by itself. I'll tell you if you tried to plug in the negative 3 that you would get a 0 on top and bottom, so plugging in doesn't work. So you multiply, doesn't matter about the positive or negative initially. Okay, I'm trying to find the factors of 6, and I want it to give me a 5. Well, both of them give me a 5, but because that was a negative, I want to subtract it to give me a 5, so it's going to be the 1 and the 6. Alright, you replace the 5x with the 1 and the 6. And this should be a negative 1, because 6 minus 1 is 5. Now, you can put the 6x first and then the negative 1x. It'll still work. Either way you do it, the process would be the same. Okay, separate it. Factor out what's in common on the first. See what's left. Factor out what's in common on the next. See what's left. These two things must be the same. And then whatever else you have left is the other factor. So that's the bottom of this factoring process that we just did. And then our x plus 3 is on the top. It's like factoring is going to work because that goes away. We no longer have a 0 on the bottom. So on top, since that goes away, it's just a 1. It does not a 0. It's not a 0 unless you plug something in and get a 0. So then you plug in your -3. So you get 2 times -3 minus 1. So -1/7 is your answer. Unfortunately, factoring doesn't always work either. So let's look at this one. Alright, this method, if you plug in a 0, you'll notice you still get a 0 on the bottom, so it's not good. There's nothing there to factor, so this is another one, and it's called conjugate. There is something called conjugate, but we're not conjugating verbs or anything like that. We're finding the conjugate. The conjugate usually is involved when there's a square root, so if you see a square root, that might give you a clue that it's possibly the conjugate. What you do, I'm going to go ahead and erase this word so I can have room to write it out, but what you do is you figure out what the conjugate is and you multiply top and bottom by the conjugate. So the conjugate is basically the part with the square root. You leave the square roots if there are, and then you change the sign of whatever it is. So if one of them's a square root and one of them's not, you do it exactly the way it's written, but you change the sign in the middle. Now, you're not actually going to multiply out the part that doesn't involve the conjugate. For example, on the bottom here, I'm not going to multiply that out. I'm going to leave that as x times square root of x plus 2 plus square root of 2. Now the top, I'm actually going to multiply that out. And something happens every time when you multiply the two conjugate pieces together. I'm going to show you using full. Square root times square root gives you that thing squared, so you just end up with x plus 2. Okay, first and last, that's going to end up with square root of x plus 2 times square root of x. It's okay to leave it like, or square root of 2, I'm sorry. And it's okay to leave it like that. Alright, and then I do the inside, and that gives me square root of 2, square root of x plus 2. And then I'm going to do the last. Square root of 2 times square root of 2 is square root of 4, which is 2. Now, you don't physically have to multiply that every time, but I'm doing it this time so I can show you what happens. This middle part will always go away. And I noticed one more mistake that I made. When I multiplied this and this, I forgot to multiply the negative with it. That should be a minus. Alright, so the middle part goes away because one's a plus and one's a minus. So now we end up with the limit as x approaches 0, and let's combine the top. X plus 2 minus 2 is just an x. On the bottom, again, we're not going to multiply, and the reason is because something will normally cancel. If you do multiply, you wouldn't have noticed it. The x's cancel, so I'm getting 1 over the square root of x plus 2 plus square root of 2. Now I'm going to plug in my 0, so I get 1 over square root of 2 plus square root of 2. You can leave it that way, or that gives you 1 over 2 square root of 2. Alright, we're going to do one more conjugate problem just so that you can see it. Alright, if I plug in a 3, alright, I realize I wrote these wrong. These are supposed to be 9s, I'm sorry. Alright, now if I plug in the 9, that's going to give me square root of 9, which is 3. 3 minus 3 is 0. 0 is on the bottom. I know I can't do those other things, so I'm going to multiply by the conjugate. The conjugate is the part that has the square root. You leave whatever's there and you change the sign. Multiply top and bottom. Doesn't matter if it's on top or bottom where you have to do the conjugate. Now, on the top, remember the part that's not the same, just leave that, don't multiply that. On the bottom, we're going to multiply. First, square root of x times square root of x is x. Square root of x times 3 is 3 square root of x. Negative 3 times square root of x is negative 3 square root of x. Those two things cancel. You don't have to do that every time. And then the last two is negative 9. What should cancel is something should cancel when you use the conjugate, as long as you've done it correctly. And then you end up with the limit as x approaches 9 of square root of x plus 3. Plug in your 9. Square root of 9 is 3. 3 plus 3 is 6. Alright, we've got one more method. And let me show it to you first, and then we'll talk about what the process is. Alright, first of all, notice if I plug in a 0 on the very bottom, I have a 0 on the bottom. If I try some other thing, it's not going to work. So this is something called common denominator. And what that means is we're going to get common denominators and then try to simplify from there. So looking at the top, there's an x plus 4 and a 4. The common denominator there would be 4 times x plus 4. It's not just x plus 4 because with adding fractions, you can't just add something to the bottom. So what happens is I need to multiply this by x plus 4, and I need to multiply that by 4 to make the denominators the same. Well, if I do that, I also have to multiply the top by that same thing. So by getting common denominators here, I now have 4 over 4 times x plus 4 minus, now this minus goes to the x and the 4, so I'm going to change it to plus and make that minus x minus 4. Alright, now on top, since I have a common denominator, I'm going to combine that. So 4 plus negative x minus 4, that's going to give me negative x. And then I have it over x on the bottom. Now, with common denominators and with fractions, this is saying a fraction divided by x. Well, when you do fractions and you multiply and divide, you leave the top and then you flip the bottom. X is like x over 1, so I'm going to change that to 1 over x. The x's will cancel, so I get negative 1 over 4 times x plus 4. And then now, and then we're still taking the limit here, now when I plug in my 0, I'm going to get negative 1 over 4 times 0 plus 4, which is 4, so 4 times 4, which is 16. Okay, let's do another one that looks similar to that. Alright, our common denominator here is going to be 3x. I'm looking at the top. So I need a 3 there and I need an x there. Well, if I do that, I've got to multiply the top by 3 and the top by x. So this gives me the limit as x approaches 3 of 3 minus x over x minus 3. And then, you know what? I wrote that wrong. 3 minus x over 3x over x minus 3. Sorry about that. Alright, so I'm dividing fractions. I'm going to rewrite that as 3 minus x over 3x times and flip the bottom. Remember, this is like x minus 3 over 1. Now, these two things, I want them to cancel, but they're not exactly the same. If I factor a negative out of one of them, then they would be the same. So it's kind of like saying negative 1 times negative 3 plus x, and then now they are the same. So I'm left with a negative on top, and then a 3x on the bottom. Now plug in your 3, so I get negative 1/9 for the limit. Alright, these 4 problems are problems that I want you to try. Just do your best on them, see what you can do from the notes that you took, and just try to work out each one. There's one of each kind of example.